Actually, you may even do a lab like that. Understand that. So let's talk about physical properties for a second. One of them you already know all about, you have since the second grade, states of matter. You can look at a substance and say that is a solid, that is a liquid, or that is a gas. And solids are rigid, they hold their shape. Liquids do not. Liquids are going to spill. Liquids, you could measure viscosity. Gases, can you measure the volume of a gas? Sure you can. So the states of matter, I would like for you to remember these three pictures. If you will remember these throughout the chemistry course, it will make your life so much simpler. The only difference between solids, liquids, and gases is the amount of energy that they possess and the attractive forces between them. What makes a solid so hard? There are strong attractive forces between them. When we get to a liquid, why do liquid particles flow? Because the attractive forces aren't quite as great. And then gases, there are no attractive forces. They have a lot of energy, they're moving really fast. So you know the difference between those. You know how to take a solid and add heat and get it to be a liquid, and then add more heat and you could get a gas. So states of matter, that's one of the physical properties of matter. I like to relate physical properties of chemicals to physical properties of people. You can look at someone maybe across the classroom and say, she is wearing a red shirt, she has black hair, and she is wearing blue jeans, right? You don't have to know her to determine those things. Those are physical things that you can see and observe. So, but you don't know her personality. You don't know where she's from, right? So that would be more like a chemical property. And we'll get to that later. But physical properties are things that can be observed without changing the nature of a substance. In other words, you don't have to do a chemical reaction to determine physical properties. For example, we have marshmallows here. You can look at them and say they are white, they are sticky. We could measure the melting point, add a little bit of heat, and we would find the melting point. You could also measure the density. This is one of the common physical properties that we measure. That substances have different densities. Marshmallows would have a very low density compared to maybe a metal or something like that. So let's look at a density problem, because I know you'll need to know how to do these. So let's say that we had a rock and we wanted to find the density. Well, density is the mass of an object divided by its volume. So the mass is easy. I can get that on a balance. But volume is a little tricky. So in this case, we had a graduated cylinder. I'm sure you've used those before. Okay. And we're going to add a little bit of water to it, up to, let's say, 20.0 milliliters. Okay. And then what happens when you drop the rock in there? It goes to the bottom, right? Well, the volume of the water goes up by exactly the volume of the rock. And so this new volume would be 21.72 milliliters. So this is what we call volumetric displacement, and it's a really handy way of finding volume quickly of an object that's small and maybe of a really weird shape. So you can see that the volume of the rock would be the difference in those two numbers. All right, let's go ahead and plug into our density formula. The mass of the rock was 12 grams, and then the difference of those two numbers, 1.72 milliliters. And then this is division, so let's use our sig fig rule. I've got 2 sig figs on the top and 3 on the bottom, so I'll round my answer to 2 sig figs. Now I'm going to show you, I don't normally like to write down what the calculator is giving me, but it's giving me all these digits, right? And you know not to write down all those numbers. So the calculator is showing this, but we want 2 sig figs, so I want to keep that figure and I want to keep that figure. Now, does the 7 kick the 9 up? Sure it does. So this would be 7.0 grams per milliliter, or since it's a solid, I'm going to call it cubic centimeters. And you know that a milliliter and a cubic centimeter are the same thing. So there is density. Actually, you may even do a lab like that. All right, let's use our density formula to find not density, but volume in this case. So what volume of sucrose has a mass of 202 grams? And we know the volume of, the density of sucrose. We look that up in a table. And we want to find the volume. So the first thing we need to do is rearrange this equation. So I've got density is mass over volume, and I want to get volume by itself. So the first thing I'll do is multiply both sides by volume. So I'll get volume times density equals mass, because those cancel. All right, and then I'll divide both sides by density to get volume by itself. So they'll cancel over here and we'll get mass over density. So all we have to do is take the mass of this, I'm going to write it over here, 202 grams divided by the density, which is 1.59 grams per cubic centimeter. Okay, now when I divide, look what happens. Grams cancel, and I'm left with cubic centimeters on the bottom of the denominator, which is really up on the top. And that's a good thing. I'm sorry, this is volume. We're solving for volume. So the volume will come out in cubic centimeters. 202 divided by 1.59. Both of those numbers have 3 sig figs, so we want to report our answer to 3 sig figs, and that would be 127 cubic centimeters. Okay, so there is an example of how you can use that density formula and rearrange and solve for another variable. I hope this helps.